Hello mate and welcome back to Let's Code Season 6. The long awaited episode has arrived where we're going to start putting things on the screen. We're not going to completely finish the game obviously, but we're going to start putting things on the screen so that we can actually see a visual representation of what it is that we've coded so far. Before we jump too quickly into that though, there's a couple of other things that we need to take care of. And the first one is this is going to be a method that we're going to put into our room class. And the method is going to return a list of all of the objects within a distance of a cell. Why do we need that, I hear you cry? Well, if we're going to create some kind of AI in our game, we need to have a maximum distance with which, for example, an enemy can see the player. So what we can do is we can say, if, for example, the player appears within 3 cells of the the position of the enemy mob, then we can basically check to see if it's in that list, because this method will output a list. So I'll quickly talk you through every line of code in this method, and then we will be able to understand a little bit better about what's going on. So obviously the first thing we need to do is define the method name. So we've got get objects in range, and then self, because we're talking about the instance of the class. And then cell is going to be the position that we want to be the center of our check, and then the distance is going to be the number of cells away from the center block we're actually going to be checking. Next thing we do is we get our starting positions x and y coordinates, and we just make them a little bit more readable. It means that we don't have to keep typing in cell brackets 0 and cell brackets 1 in the different places that we need them over here. And then we create an empty list called output list, where we're going to put any objects that occur within that range of the position that we give it. Then what we're going to do is we're going to loop through every block from minus distance to plus distance on the x-axis. So in other words, if we were at block 5 and we were checking with a range of 5, we would start at 5 minus 5, which is obviously 0, and then we go to 10, which is 5 plus 5. So we're going 5 blocks in each direction. Then we're going from minus our distance, again minus 5, to plus 5 in the y direction. So we're going to check everything in a 5 by 5 grid around our block. Then we're going to get our new x and our new y positions, which are going to be the positions of the cell we're taking. So x and y are the position that we are, let's say for argument, we're standing on x and y. We want our block that we're going to check in each loop iteration of the loop is going to be the x position minus the I position and the y position minus the j position, and then it will loop through every single block within that 25 blocks that we are checking. And then we're going to check, before we do anything else, we want to make sure that our new x and new y are within the size of the matrix, because if we were to try and reference a negative number or a number that's greater than the size of our room matrix, we will get a exception thrown. It will cause our game to crash. So we're saying it needs to be that new x is greater than or equal to 0, and new x is less than the length of the matrix in the x direction, and that the new y is greater than 0 and new y is less than the matrix in the y direction. Then if it passes that check, we're going to say if the item in that cell is not 0, remember that we use 0 to indicate empty space. If it's not that, then we're going to add whatever is in that space to our empty list, and then we're going to return the list once we've gone through and checked every single cell. And that will enable us to be able to check to see if the player is within a certain range of the entity or whatever. Many different things we can use this for. The next method we're going to create is going to be a getIcon property that we're going to put into our game objects and our entities. This is the method that I've written for the entity class, but essentially the method will be the same for every single one. You just want to change the path that we have in the output string. So as you can see, I have images slash icons slash something slash 0.png, and then what I replace the curly braces with is actually an icon variable, which we'll talk about in a minute. And then we just say if ren'py.loadable, in other words, can ren'py load a file from this path? If it can, then we're going to send this out to whatever method is asking for it. If it can't, then we're just going to return this images /icons /default.png. which is a file that you're going to need to create, and it'll need to be the same size as your default cell size so that it is at least something that's going to occupy that space. Now, as you can see in the top of our entity class, what I've now added is an icon parameter and a self underscore icon equals icon line. So it's the same kind of thing as all the previous variables and fields that we've added. So now when you create an entity, you will need to declare what its icon file is called, and then the get icon method will be able to locate that file and output it so that our screen code will be able to find files that it can actually put on the screen. It's just a simple way of displaying each thing. So for everything that we create, every entity or game object or anything else that has an icon that we create, we need to specify what the icon is called. Now, if you wanted to take a shortcut, you could use the name, but the problem with that is that if we do decide to have some kind of textual feedback on the screen which reports in either a box or a tooltip what it is that you're hovering the mouse over, you're going to want the name to be sort of pretty and look readable, whereas if you're using that as a file name as well, then you can't afford to have too much pretty in there. So there is going to be a bit of a conflict in that regard. The next method that we need to add to our room class is going to be called getBackgroundImage. Again, it's going to be a property. And what this method is going to do is we're going to return a file name again. This time it's going to be images backgrounds. And the name is just going to be the room type. Then we're going to check if the output is loadable. If it is, we're going to return that file name. Otherwise, we're going to resort to a default background image. Again, this background image you're going to have to create yourself. It's going to need to be 1920 by 1080p or whatever the resolution of your game is so that it occupies the entire screen. Now we're getting into the screen language. First thing we want to do is create a new file called screen main UI or something like that. It needs to be .rpy file. And inside that file, what I want you to do is type in screen and then main UI. This is going to be the UI that is basically displayed on the screen all of the time. And then all of our other screens will be used from within the main UI screen. So all we have in there at the moment is use BG image and use icon screen. Those are two separate screens that we're going to create in a moment. But we're also going to put a button in the bottom right hand corner of the screen which just reads next in it. The color #FFF is the hexadecimal color white for the text. Then we've got the background of the button itself is just a gray color. As you can see, background #55616E as a hexadecimal color as well. And that's just a nice gray color for the background of the button. And then we're going to say align. That's just going to tell you where the button is going to be positioned. In this case, it's going to be 90% of the way across the screen to the right and 90% of the way across the screen down. So it'll be in the bottom right hand corner of the screen. And we want this button to just return none. So action return none. Make sure that you capitalize the R. And that's going to, all this button needs to do is just basically be an interaction of some kind, because none of the other things that we're going to put on the screen at the moment are going to be interactable. The next screen is almost barely worth mentioning. It's the background image screen. Now, I have written this in 4 lines of code. You could do this in 1 if you wanted to, but I've just done it this way to make it more readable. So we've created a new screen in a new file and it's called BG image. If you remember, our main UI uses BG image. And all this does is it gets the player's position. It splits the player's position down into an X and Y coordinate, which we then use to reference the room, which is game.gameMap.getMatrix X and Y. That's the player's position. So this is the room we're in. And then if you remember, we added a getBackgroundImage method or property to our room class only moments ago. So now we're using that to get the image file that we need for this room. Now remember, if this room doesn't have a background image, or rather the background image doesn't match what we're expecting, it will still return the default background image that I've created and added to my game file. So regardless of whether or not this file exists, you will always have something to display on the screen. It means that the game won't crash if it tries to reference a file that doesn't exist, which is kind of why we've done things the way we have. This is really the screen where most of the magic's happening, and this is our icon screen. Again, create a new file call it whatever you want to, and then inside that file we'll put screen icon screen. This is the other screen that is used from the main UI screen. This is the screen that's going to display the icons for all of our things that are in the grid. So what we need to do is we need to get the player's position and turn it into X and Y coordinates so that we know which room we're referencing, and then we're just going to take a reference of our matrix. So we're just going to call this current matrix, and then we're just going to say current matrix equals game.gamemap.getMatrix xy.getMatrix. So this is the matrix for our room, and then we're going to set our icon size. Now, using constants in Python is quite useful because it means rather than messing around with having to change the values in every single one of our declarations down here, we can just say icon size, declare it once, and then we can reuse that value many, many times, which you can see we do down here. We're also going to set dimensions of our frame if we were going to use a frame, which we actually don't, but it's useful to have this number anyway, because we might use it further down the line. So we get a Y dimension and an X dimension, which is basically our icon size times by the number of cells down, and our icon size times by the number of cells across. So we create an X and Y resolution for our grid. Then we're going to loop through our matrix's Y dimension. So we're going to loop through each row in our matrix, and we're going to use enumerate, because not only do I want to be able to access the items in that matrix, but I also want to know what cell it is, in other words the coordinates. So we use enumerate. iCount is just the name I've chosen for the variable that's going to be the first when using enumerate. The first variable used is going to be the index, and then the second is going to be the item at that position. And then what I'm going to do is I'm going to loop through the items in that row one at a time. And again, I'm going to enumerate, and that will give me my X and Y coordinates, or in this case, it'll be iCount and J count. And now we're saying if the item in the cell that we're currently looking at is a 0, in other words, if it's an empty space, then we're just going to add a default.png, which I've created here. This is basically just a white square with an opacity of 1. In other words, really, really, really see-through. You can just about barely make it out on the screen when it's displayed, but it's just there to fill that space. I mean, we might even remove those once we've done them, because we're not using a grid, so we don't actually need to display anything. I'm just doing this for the sake of being able to see what size my grid is, really. And then we're going to set the anchor position to be the left-hand corner on the bottom. So 1.0 is our Y for our anchor. Anchor is a command that tells Ren'Py, when you display this image, the X and Y coordinates I give you correspond to this part of the image. So in this case, I'm saying the bottom left-hand corner. And then I'm just setting the position to be iCount times the icon size. In other words, 45 times 0 if it's the first item in the list. It'll be 1, 2, 3, 4, all the way up. And the Y coordinate will be the J count times by the icon size plus the icon size. Because if you remember, we are using the bottom left-hand corner. So we need to actually bump up the icon's size by, or bump up the position by 1 times the icon size, so that we get a the positions right. Just take my word for it, it works. And then the same thing again, we're saying if it's not a 0, it must be something, either a game object or an entity or the player. And if that's the case, then add the whatever we get from the getIcon method of that piece of code, that object or that game object or that entity. What they actually, remember, I told you to add the getIcon method to all of them. So this will just reference that, and it will again set the anchor as the bottom left hand corner, and its position again will be iCount times icon size for the X position, and then JCount times icon size plus icon size for the Y position. And that will basically mean that we've created a grid without using a grid. The reason we're not using a Ren'Py grid is that there are limitations within those that may prevent us from being able to use this game properly. For example, if you were to walk into a room with nothing in the grid would be squished into the bottom left hand corner. It wouldn't work properly. There are just too many restrictions in using VP grids or grids that we can just bypass simply by using X and Y coordinates that we multiply by the icon size, which is what we've done here. The last thing we need to do to get this to actually work is we need to make some adjustments to our start method or our start label. So as you can see, I've got here, we've still got game equals game, we've still got output string, game created, and now we've added playing equals true, and we've created a new health potion. And as you can see, we've actually added that health potion to the room that we're currently in, which is 2,2. This is just so we've got something to actually look at when we go into our code. So we're saying while playing, in other words, we've set playing to be true, and then we're saying while playing is true. Then we're going to call UI return equals renpy.callScreen main UI. So we're saying that this variable UI return is equal to whatever we get back from our screen main UI. This is basically just a way of displaying the UI on the screen and keeping it on the screen when we do an interaction. And because it just keeps displaying the screen and keeps waiting, and UI return will basically be whatever it is that we have got back from the main UI. And in this case, we can use it to move the player around the screen. We can get it to do a whole number of things, but that's primarily how we're going to get our whole thing to operate. So assuming that you've managed to copy all of the code that I've told you and you've put it in the right places, this is more or less what you should be seeing on the screen at the moment. Obviously, your images are going to be different. Your background image isn't going to look like mine. Your next button should look identical because it's all created by code. And obviously, your health potion icon is going to look different as well, because as you can see, I've just used a temporary sort of red square with health written on it at the moment. But if you look really closely at this, you can actually see the slight color difference on the left hand side where the cells have that empty cell within them. Now there is a bit of a problem in that I can see very clearly here that our room is taller than it is wide, which means that our X and Y coordinates are back to front somewhere. So we can sort that out in the next episode. But ultimately, as long as we now have a visual representation of our room's matrix, we can get a little bit further into the coding now, and we can actually be able to see what is happening when we make changes. So that's everything we're going to cover today. Hopefully you found that useful and you managed to follow along. Let me know what you think in the comments below, and I will see you again in the next one. But until then, you take damn good care of yourselves, alright? Bye bye.